Hello everyone. Today's session is on probability of playing cards. Probability on playing cards is what we are going to do this time around. So as usual, I hope you follow me very closely so that you understand this lesson, you understand what I'm going to present to you, so that you again continue to do prediction on mathematics basis. Probability on playing cards. Again, first of all, what we need to understand what is playing cards so that we can therefore do prediction on what is going to happen with playing cards. So what is playing card, by the way? Playing cards, these are defined to be objects which occur together in a box of either 52 or 54 cards. So actually these objects are very familiar all over the world. I hope in some way or in one situation or another you might be encountered with that kind of playing. So playing cards, actually we'll know later what are these, by the way, in terms of identifying one card after another. But actually playing card, these are objects which are used as a game of playing. So some people are using these cards for fun, for playing for fun. Others are using these cards to do gambling. Now, so these playing cards got a lot of names, one card after another. So they are named and specified, each in its own name. So we've got names of playing cards here, and here I'm going to go with a pack of 52 cards. So with these playing cards, there are cards which are called diamond. And this one is the card which look like this. So here there is a diamond one. So a playing card which has been marked as a diamond, so it is also called a diamond card. Another card is called king card. This king card is always a card with the letter K. So it is a card specified by having a letter K. So this is called a king card. If you are familiar with playing card, any card you might pick which is lettered to be K, so that card is always going to be called king card. As usual, also there is a card called queen card. A queen card also is a card which is marked as Q. So queen card also is marked to be Q. And another card is called spade, and this one looks like this. So there is a shape like this here. So a card like this one is called a spade. Another card is club and look like this. So a club so this is a card with this shape is called a club. And another card is a head card. This card is having a head shape. So this one is a head card. And another card is jack card, and it is identified by a letter J. Another card is an S. An S card is identified by having a letter A. So these are names which appear from playing cards, and these cards are always used to make prediction, and thus prediction others take advantage and go further to do gambling. And others who are not interested with gambling, they always use those cards to make fun, at least to find time to be happy with kind of playing. Now, so actually I'm talking about cards which are of a total 52. Now diamond card, by the way, they are 13 diamond card from available 52. And king card, they are 4 in numbers. And queen card, they are 4 again in numbers. Spade, these are 13 in numbers. And club, they are 13 in numbers out of available 52. And head card, they are 13 in numbers. Jack card, they are 4, and ace card, they are 4. So actually these are the slot or the number of cards of each name or of each type from available 52 cards. So with this information, at least will be enough for you to answer some kind of questions which are concerning with probability when it comes to playing cards. Let's check a little more on the tree diagram of how these cards have been identified or branched or structured, I can say. So let us check the structure or kind of tree diagram which portray how these cards they are from available 52 cards. And from there we can check some kind of examples on how to answer questions on probability on playing cards. Okay, let's check that. Wow, we continue with structure of playing cards. The structure is this one, that you have a total of 52 playing cards, but among these 52 playing cards, 26 of them they are of red color. 26 of playing cards they are of red color, and the remaining 26 are black colored. But from red colored cards, which are of 26 in numbers, half of the 26, which is 13, are head card, and the remaining half is diamond card. So what does this mean is that head card and diamond card, both of them should be red in color. Head card and diamond card should be red in color. You can prove me right if you are familiar with this kind of game. And again, black card is a combination of club and spade. Club, they are 13 in numbers, and spade, they are 13 in numbers again. So spade and club together, they form a total of 26 black cards. So this is the structure which is very important, which can help you to do some kind of question based on probability on this kind of game. Now is a very perfect time to check examples on how you can answer questions. So coming to example number one. The question says, one card is picked at random from a pack of 52 cards. So you're asking, what is the probability of getting a red card? What is the chance that a red card will be picked? And also, what is the probability that a diamond card will be picked? And again, part C, the probability that an ace card will be picked. Okay, so to answer this question, especially part A, first you have to let R to represent the event that a card is red. Assume R is representing the event that the card which has been picked is red. So from here, we want to know how many red cards from a pack of 52 cards. How many red cards are there? So with this tree diagram, with this structure, you can see how many red cards. So there are 26 red cards out of 52 available. So it's very simple now to answer this kind of question. So what we do is to break down the important informations which will be used to plug into the probability formula. So the number of red cards, they are 26, while the number of sample space, which means the number of cards available. So the total number of cards available, they are 52. How do you know this? Because it has been said from the question that the total number of cards there is 52. So from probability of red card, so the event now is red card, so it's not necessary that at all times you use letter E. It's not necessary, so you can replace E with R. So the probability of drawing red card is equal to number of red card divided by the number of sample space. If you answer this one, the number of red card is 26 per number of sample space, which means the number of cards, they are 52. So if we simplify, you get a half. So the probability of drawing a red card is a half a chance for sure. So this is how you solve part A. Now we continue with part B. With part B, the event is a card should be diamond. A card should be diamond. So you have to let a letter D to represent event that a card is diamond. Assume that the card picked is diamond. Now how many diamond cards? How many diamond cards from a pack of 52 cards? Now, so if you are familiar with the names of cards and the number of cards available, so you have to know for sure that the number of diamond cards there, they have to be 13. They have to be 13. And again, the number of sample space remain the same, 52. So now, the probability of drawing diamond card will be equal to the number of diamond card per number of sample space. And if you plug the information, the number of diamond cards, they are 13, divided by number of sample space, they are 52. So simplify this fraction, you get 1 out of 4. So this now is be the answer. This will be the chance that a diamond card will be picked at random from a pack of 52 playing card. So this chance is quarter a chance. It is quarter a chance. So this chance is very smaller compared to the chance that red card will be picked. Why? Because there are many red cards compared to diamond cards. So diamond card they are 13 and red card they are 26. So if the number of elements becomes many, even the chance that event will occur is also increased, becoming bigger and bigger. Now part C. Part C is required to find the probability that an S card will be picked. An S card will be picked. So part C, again, the number of sample space remains the same to be 52, but the number of A representing S card. So A is now representing the event that an S card will be picked. Now the number of S card available, they are 4. So you can now define that probability of S card will be equal to the number of S card per number of sample space, or the number of cards available. Now this becomes 4 divided by 52. If you simplify this, you get 1 out of 13. So this is now a chance that an S card will be picked at random. I hope this is very clear. I hope my presentation helps you a lot to answer this kind of question. We'll check a couple of more examples to make sure that you familiarize with playing cards and how to answer questions concerning the probability on those playing cards. Thank you. Let's see what is going to happen next. Right, with example number 2, students, you are asked to find the probability of drawing a king card from a deck of 52 playing cards. Actually, I should continue and say it's random. It's random because we need to make selection at random without a prior knowledge. What are you picking? That is random selection. Now, so what is the probability of drawing a king card, drawing a king card from a deck of 52 playing cards at random? Actually, what is the question trying to say is that what will be the chance that if a card is picked at random, then after observation, that card will be a king card, that card which is lettered K. What will be the probability to do that? Now, to do this question as a part of solution, first you have to suggest what will be the event. So suggest the event, and we say that let K represent the event that the card is king. Let K to represent the event that the card is king. Now, how many king cards are available from a pack of 52 playing cards? Now, actually there are 4 king cards, but the number of cards available is given to be 52 playing cards. So this represents the universal set, which contain a total of 52 elements, 52 objects. So now you can say from the formula that probability of drawing king card will be equal to number of K per number of sample space. You solve this in order to find the probability that a card will be king. So you have to substitute number of king cards available out of number of all cards available. So this is supposed to be 4 out of 52, and you simplify this, you get 1 out of 13. So actually this is now the probability of drawing king card. It is mathematically expressed as 1 out of 13. So thank you, and I believe with this presentation you can now be comfortable to answer some kind of question, the basic one, which involve probability on playing cards. I hope this helps you. Thank you.